I'm Daze Thomas, Assistant Professor, Department of Artificial Intelligence and Data Science, SNS College of Engineering. Today, let us discuss about process scheduling. Process scheduler selects among available processes for next execution on CPU core. The goal of process scheduling is to maximize the CPU usage and quickly switch processes onto CPU core. These are the two main goals of process scheduling. Process scheduling maintains a scheduling queue of processes. There are two types of queues. One is ready queue and another one is wait queue. Ready queue has a set of all processes residing in main memory ready and waiting to execute. In waiting queue, a set of processes waiting for an event. It can be a input output requirement or anything. Processes migrate among the various queues. So these are the two types of queues process scheduling has. One is ready queue, another one is wait queue. This is the structure for a ready queue and wait queue. Ready queue has a head and a tail. Head points to the first process and tail points to the last process. Every process will have a process control block in which all the details of that particular process will be saved. And you can see the structure of wait queue also. Here also you have a head and tail. Head points to the first process and tail points to the last process, and all the processes are interconnected. This is the representation of process scheduling. In process scheduling, you can see a ready queue. Initially, a process enters into the ready queue, and if the CPU is ready for execution, process will be allocated a CPU, and after execution, it gets terminated. This is a normal procedure. Suppose if any process has an IO request, it goes to IO request state, and then it will wait for the IO, and after the IO is assigned, it will again move to the ready queue and the CPU will be allocated and the process will get terminated. And suppose a new child process is created, again the process will go to waiting state until the child process gets terminated. When it gets terminated, it will again move to ready queue and the CPU will be allocated and gets terminated. Or if any interrupt comes, it will again move to the waiting state and it will move to the interrupt waiting queue. After the interrupt is being executed or terminated, it will again move to ready queue and then the CPU will be allocated and it moves to the termination. So this is the representation of process scheduling. Next we'll see how a CPU switches from one process to another. It is called context switch. It occurs when CPU switches from one process to another. In this diagram, you can see there are two processes, process P0 and process P1. Initially, process P0 is getting executed and suddenly an interrupt or a system call comes. Then you will save the current state of process P0 in its process control block and it moves to waiting state. So now process P0 is in idle state and it will reload process P1 and the state of P1 will be now in execution state. After execution, it gets terminated and the current state of process P1 will be saved in the process control block and it gets terminated. So again process P0 will be reloaded and gets executed and then gets terminated. So this is how a process, so CPU switches from one process to another. So I hope today's topics are very clear to you. See you in the next class. Thank you.